Jai Hind everyone. My name is Mamta Pant and I'm working as an assistant professor in IT department of Ajay Kumargar Engineering College, Ghaziabad. Today we are going to discuss functional dependency topic used in DBMS. So these are the topics we will cover in this video lecture. First is what is functional dependency. Next, types of functional dependency. After that, attribute closure, then Armstrong axioms, equivalence of functional dependency, and at the very last, canonical cover, which is also known as minimal cover or irreducible set of functional dependency. Let's get started. First of all, we need to understand what is functional dependency. We say an attribute B has a functional dependency on another attribute A, and this can be written as this. Let's understand this with the help of an example. Suppose we have a table. This table. And name of this relation is R. We have two attributes at A and B. We have some values here and we have another values here. Okay. So with the help of A, I can tell the value of B. Means if I will tell you the value of A, can you tell me the value of B? Yes, I can tell you the value of B. For example, I am saying if I have the value of A is equals to 1, can you tell me the value of B with respect to A is equals to 1? Yes, I can tell you the value of B is equals to A. Now, if I am reversing this example, for example, I am telling you that the value of B is equals to A and tell me the value of A. Can you tell the value of attribute A with respect to B is equals to A? Here we have A in two places. Okay, so we have two values for B is equals to A. First is 1, another one is 4. So with the help of B, you cannot tell the value of A, but with the help of A, you can definitely tell the value of B. Why is it is so? Because all the values of A are distinct and unique. That's why you can tell the value of B. But here the values of B are not unique and distinct. They are repetitive and they have duplicacy in their values. So with the help of B, we cannot tell you the value of A. So now I can write a statement that A tends to B. This is known as functional dependency FD. A tends to B. How we will read it? We will read it that with the help of A, if you tell me the value of A, I will tell you the value of B. So, is this equivalent of mathematical function? Now, next question arises. Mathematical function. Mathematical functions like fx of y. Here, what we say in mathematical function we say if I will put the value of x, we can compute the value of y. But in case of DBMS, on the value of A, I cannot compute. I will search the value of B. This is not a mathematical function. Remember this thing. This is the misconception some students have that this is equivalent to mathematical function. No. In mathematical functions, on the value of x, I can compute the value of y. But in case of DBMS functional dependency, on the value of A, I will, with the help of value of A, I can search the value of B in the database. So this is the proper definition of functional dependency. Next, let's have an example. Suppose we have track of employees. Okay, we have employee address, email address, and employee number. So with the help of employee number, I can easily find out the email address of an employee. The next is suppose there is a relation. There is a relation A. Okay. Now R is the name of relation. A and B are the attributes in our relation. These are the attributes. So A belongs to R. A is a subset of R. B is also subset of R. We can write it down like that. Next, we can see that A determines B. A determines B. Means with the help of A, with the help of the value of A, I can search the value of B. If I'm having the value of 101, I can tell the value of B, that is Cn. So here in this dependency, A is known as determinant and B is known as dependent because values of B is dependent on the value of A. Next, okay, let's have an example. If I have square function, okay, suppose I am putting the value of x is equals to 4 on the x is equals to y is equals to x square. On putting the x is equals to 4, I will get the value of y is equals to 16. Is this possible that I will again put the value of x is equals to 4 and now I will get the value of y is equals to 18? Is this ever possible that on the same value of x, I will get the different value of y for the same function? This is never gonna be possible. This will never possible in case of this. So the conclusion is that on the same value of x, we must get the same value of y. Here we also get 16, not 18. So this is the example of So this is the proper definition of functional dependency. Means if suppose we have a table. Suppose we have a table and we have alpha here and we have beta here. This is tuple T1, rows is known as tuple, and this is tuple T2, some tuple T1, subtuple T2. So what the definition of functional dependency said, if T1 of A, T1 of this is equals to T2 of this is equals to T2 of this, means on the two same value of alpha, we will get T2 of B, T2 of B is equals to T2 of, here we will write T1 of B is equals to T2 of B. On the same value of alpha, we must get the same value of beta. That's why it is known as the functional dependency. This is the technical definition of functional dependency. If A tends to B, then on T1 of A, if T1 of A is equals to T2 of A, then T2 of B must be equal to T2 of B. So we can read it also as B can be found on the basis of A. This is the functional dependency. This is the another example of functional dependency. Here, with the help of A, I can search the value of B. So here is also a functional dependency. A tends to B. Next, types of functional dependency. Functional dependency basically is of two types. First is trivial, another one is non-trivial. Let's have a practical example. Suppose I am telling you the value that my name, my roll number and my address. I am telling you my name, my roll number and my address. And after getting these information, you are telling me my roll number. This is a functional dependency. I am telling you some information and you are also telling me some information. This is functional dependency and valid dependency. I am telling you my name, my roll number and my address. And irrespective of these information, you are telling me my roll number. Okay, so this comes under trivial dependency. This dependency is valid. You are telling me the right information, but not informative. Not is on. I have already my roll number in my information, so I really don't need of these roll number information from you. I need some more information, some informative data. So the trivial dependency is functional dependency, like if A and B both are the attributes in a relation R, then if B is a subset of A, we can also write it down as suppose beta is a subset of alpha, proper subset of alpha, and here is a functional dependency, alpha tends to beta, then this is known as trivial functional dependency. For example, let's take an example. This is the example of trivial functional dependency. I am telling you the value of A and B. With the help of A and B, you can search the value of B. This is valid. This dependency is valid. Dependency is valid, but not informative. Because you are not giving me something new information which is of mine use. Okay, so this dependency is known as trivial dependency. This is valid but not informative. Other case is other types of functional dependency is trivial dependency. Suppose I am telling you my name, my roll number, and after using these information, you are giving me my name, my roll number and my address. You are giving me now some additional information. So this is called as trivial dependency, where beta is not a proper subset of A is known as trivial dependency. This dependency valid? Yes, definitely dependency and also informative. Why informative? Because new attribute is found with the help of given attribute. So we have two types of functional dependency. First is trivial and other one is non-trivial dependency. Here we have some practice problems on the functional dependency. Suppose a relation R is given and this is the table of relation R. Now I need to tell that the following dependency is valid or not with the help of this table. So let's get started one by one. First dependency is A tends to BC. Here, what is the meaning of this functional dependency? With the help of A, I can search the value of B and C. Okay, let's see the table. Here, the value of A is, okay. Now, what was the definition of functional dependency? T1 of alpha is equals to T2 of alpha. If this condition is true, then T1 of beta should be equal to T2 of beta. So the same value of alpha A, we should get the same value of B and C. So here search the same value of A. Here we have repeated Z 3 times, Z, Z, Z. So for these 3 Z's, we get same value for B and C. The value of Z is 2, 3. This value of Z, 2, 3. Value of Z, 2, 3. So here for all these Z, we get the same information from B and C. So this dependency is valid. Now, let's check the next dependency, that is DE tends to C. On the value of DE, after getting the value of DE, I can find or search the value of C. So, let's first identify the same value of D and E, 4, 5 and 4, 5. Here, on 4, 5, I am getting the value of C 3 and on 4, 5, I am getting the value of 3. So, on the same value of D, I am getting the same value of C. So, this is also valid. So, this is also valid. Next check, this is valid and this is also valid. This is valid and this is also valid. Now check for third one. C tends to DE. First check the same value of C. We have to get the same value for D and E. On 3, 4, 5, on 3, 4, 5, on 3, 5 and 6. This is the difference. Here on 3, I will get 4 and 5. Here on 3, I get 4 and 5. Here on 3, I get 5 and 6. So this functional dependency is invalid. Now, check for another functional dependency, BC tends to A. Same value for BC. First of all, we have to find it out, 2, 3 and 2, 3 and 2, 3 and check the value of it respective. On 2, 3, I am getting Z. On 2, 3, I am getting Z. On 2, 3, I am getting Z. So, this functional dependency is also valid functional dependency. Okay. So, first functional dependency is valid, second is valid, third one is invalid and fourth one is also valid. Now some more practice problems on functional dependency. Take this. For question number 1 and for option number 1, both functional dependencies should be valid to get question number 1 is valid. So let's check them one by one. Is this functional dependency is valid on xy, on the same value xy, I am getting same value of z, xy. 1, 4, 1, 5, 1, 6, 1, 3. There is no repetition of xy. So, this is valid functional dependency. Now, check for z. Here, 2 times 2 is repeated, 2 times 3 is repeated. So, on 2, I am getting y value 4. On 2, I am getting 2. Here, the violation of functional dependency rule. Okay? So, this is invalid. This functional dependency is invalid. Now, check for another. YZ. On YZ, here is no repetition of Y and Z. So, this is valid functional dependency. Now, Y tends to Z. All the values of Y are different or unique. So, we do not need to check for the value because no value is repeated. We have to check for functional dependency on repeated value or duplicate values. So, this is also valid. So, this functional dependency is valid. Next, check for Y and Z. values of y and z are distinct, so we do not need to check for the further conditions. So this is valid functional dependency, and x tends to z. On 1 we get 2, on 1 we get 3. There is the violation of functional dependency condition, so this is invalid and this is combinedly invalid. In next example, x z tends to y. On x z 1 2 1 3 1 3. Here 1 and 3. 1 and 3 is repeated. On this we have to check the value of y. We have different values of y, so this is invalid. One is invalid in AND operation, so other one either valid or invalid. Is it completely, it would be invalid. Okay, so it would be invalid. The values of A is repeated or not. Value of A is repeated, yes. On the repeated value we have to check the value of B. 1 2 1 4. Invalid. So this is invalid functional dependency, because in AND operation both functional dependency should be valid to get the valid functional dependency. So now let's have a check on this. On value of BC, value of BC are distinct, so this functional dependency individually is valid, but in combinedly this is invalid. Now check the value of C. On 4 2, on 4 5, this is invalid functional dependency. And now check for CA. 1 4 3 4 3 2 1 2. Here is no repetition of CA, so this will be valid functional dependency, but it combinedly invalid. Now check for the value of B. Value of B are distinct, so we need not to check the functional dependency condition. It would be valid functional dependency. Now check for A and B. 1 2 3 5 3 7 and 1 4. These are distinct, so this will be the valid functional dependency. Combinedly it will be valid functional dependency. Next, on the value of A. Value of A 1 4 1 2. So this will violate the rule of conditions of functional dependency, so this is invalid. And BC tends to A. On the value of BC, value of BC is distinct, so this will be valid functional dependency, but it combinedly invalid. So only as option number 3 is your valid functional dependency. Okay, so here 3rd will be the valid functional dependency, and here 2nd will be the valid functional dependency. You can practice on more questions for clear the concept of functional dependency. Now, next is attribute closure or closure set of attributes. Attribute closure of an attribute set A can be defined as a set of attributes which can be functionally determined from A. It is denoted by F plus. Functional dependency is denoted by F plus. Let's have an example. We have a relation R1, A, B, C, and these two functional dependencies are given. Basically, functional dependency comprises of direct or plus indirect. What is the meaning of direct or indirect here? Let's suppose we have to find out closure set of A. Sorry, here should be closure set. So we have to find out the closure set of A. With the help of functional dependency, I can easily identify that. With the help of A, I can search the value of B. So if I'm finding the closure set of A, so I am having A already. I have the information of A already, and with the help of information of A, I can search the value of B. So I can write it down B here. But here you can see in another functional dependency, with the help of B, I can search the value of C. And right now, I am having the value of B, and with the help of this value, I can search the value of C. So with the help of B, I can now search the value of C. So basically, if I am having the information of attribute A, with the help of this information, I can fetch A, B, C. So this B is direct closure set of A, but this C is indirect closure set of A. Because after seeing the functional dependency, I cannot determine with the help of A, I can find the value of C. But while I am solving this with the help of closure set or attribute closure, I can easily find out that with the help of A, I can also get the value of C. So the closure set is a combination of direct or indirect functional dependencies. Okay. So let's have an example. Here, closure set of A I have already have, and with the help of A I can search the value of B, so AB, and with the help of B I can search the value of C, so ABC. So this is the closure set of A. Closure set means all the attributes we can find out with the help of a given attribute. Here, with the help of attribute A, we can find out the information B and C also. Let's have another example. There is a relation R to A, B, C, D, E, F, and these are the functional dependencies. I need to find out the closure set of B. Closure set means with the help of D information, which attributes we can find it out. So with the help of D, I can find out D easily. This is trivial functional dependency. Now, with the help of D, I can find out A and F. So A and F also added. Now I have three information. Attribute A, attribute D, and attribute F. Now, with the help of A, I can find out the value of B. So, we can add B here. Some another functional dependency may helpful? No. No more further functional dependency are helpful. So, this is the closure set of D. Now, next find the closure set of DE plus. So, I have DE already. With the help of D, I can find out A and F. And with the help of A, I can find the value of B. And next, can I get, oh yes, with the help of E, I can find it out C and F. So all the attributes are driven from the help of D and E. So this is the closure set of D. Now, there are some rules known as Armstrong's rules or Armstrong's axioms used for find out the closure set of an attribute. Some rules are known as primary rules. Here we have three rules. First one is your reflexive rule. If Y is a subset of X, like Y is a subset of X, then there would be a functional dependency X tends to Y. Next is your augmentation rule. If X tends to Y, then XZ tends to YZ. Means adding a attribute on left or right hand side does not affect the functional dependency. Next one is your transitive rule. If X tends to Y, with the help of X, I can find the value of Y, and with the help of Y, I can find the value of X. So basically, with the help of X, I can find the value of Z also. This is known as transitive rule. These three rules combinedly together also known as rat rules. Reflexive, augmentation, transitive. So combinedly these rules are known as rat rules famously. Next, there are some secondary rules also. Now, first secondary rule is union. If X tends to Y and Y tends to Z, we can combinedly write that X tends to YZ. Here with the help of X, I can find the value of Y, and here with the help of X, I can find the value of Z. So combinedly with the help of X, I can find the value of Y and Z. Next is your decomposition rule, just opposite to the union rule. If X tends to YZ, if with the help of X, I can find the value of YZ, I can decompose this functional dependency into two, X tends to Y and X tends to Z. Next is your pseudo transitivity rule. If X tends to Y and WY tends to Z, then WX tends to Z. How is that possible? This functional dependency is known as, with the help of augmentation, I can add W here. So, and this is WX and this is WY. We already have WY tends to Z. So we can replace this with the help of Z. So WX tends to Z. This is the proof of pseudo transitivity rule. Next is your composition rule. If X tends to Y and Z tends to W, then Z tends to WZ. How we can prove that? This is given functional dependency. We will add Z on left or right hand side both. Now this is also given functional dependency. So I can also the ZW. This functional dependency is also given. When we will union this functional dependency, we get this. And after removing Z, we get Zx by W. So this is the proof of decomposition rule with the help of decomposition rule. So these are the some Armstrong's axioms rules with the help of which we can find out the closure set of a given attribute. Next, let's have some practice problems on attribute set or closure set of a functional dependency. Here, 3 functional dependencies are given and we have to find out the closure set of AC. So, closure set of AC. We already have AC. With the help of A, I can find the value of B. A, B, C. Now, I have BC. Yes, with the help of BC, I can find the value of D and E. So, I can I, B, C, D and E. Should I have A, E and G? No, I do not have A, E and G. So this functional dependency would not be apply on my closure set. So this is the closure set of AC plus. Now on next question, closure set of B. B I already have. With the help of B, I can search the value of D. So B and D. Could I get further information? No. Further information could not be get with the help of B. So this is the closure set of B. Next, I have to find out closure set of A and B. With the help of A and B, I can find the value of AB, and with the help of AB, I can find the value of C, and with the help of BC, I can find the value of A and D. With the help of D, I can find the value of E. So this is the closure set of AB plus. Next, we have to find this question. Is this valid or invalid? For this, we have to find out the closure set of BD, BCD. BCD closure set, BCD. With the help, we don't have A, we have CD. We can find B, C, D and E. With the help of E, I can find C. We already have C. With the help of D, I can find A, E and H. A, E and H. So you can clearly see that with the help of BCD, I can find the value of H. So this is valid closure set. Now on next question, we have to find out the closure set of AG plus. So we have AG already. With the help of A, I can find out the value of B and C. A, B, C and G. With the help of CG, I can find out the value of H. With the help of CG, I can find out the value of I, such that we can find all the attributes with the help of AG plus. So this is the closure set of A and G. So such that you can practice on more questions to solve more questions on the closure set of attributes. So for now, thank you so much. In the next video lecture, we will discuss more topics on the functional dependency.